Welcome. Today also we take few important problems on definite integral. First of all, the problem is if 2 times 0 to x ft dt is equal to x square plus x to 1 ft dt, then f1 is equal to option is -1, 1, 2/3 and 0. That problem was given in West Bengal Joint Entrance Examination 11. To solve the problem, let us apply a trick. Let ft, it is a function of t. Suppose it is derivative of that function, that is, it is phi dash t. Derivative is taken with respect to t, so that the problem become 2 0 to x phi dash t dt is equal to x square plus x to 1 phi dash t dt. Now it is integration and derivative, so it become 2 into phi t, and limit between 0 to x square plus same problem, this is phi t, integration of phi dash t is phi t into from x to 1, so that it is equal to 2 phi x minus upper limit 2 phi 0 is equal to x square plus put upper limit phi 1 minus phi x. Now it's a function of x only. Now differentiate both sides with respect to x, so that it become, they together, this and that, they together is 3 phi x is equal to x square. This become plus 2 phi 0 plus phi 1. Now differentiate both sides with respect to x, so that this become 3 phi dash x is equal to 2x. This is a constant, this is constant, so 0. So that phi dash x is equal to 2/3 into x. We have to find phi dash x, we have to find f1, but phi dash t is equal to ft. So phi dash x is equal to fx is equal to 2/3 into x. We want f1, therefore f1 is equal to 2/3 into 1, that is 2/3. So this option is correct. Yes. Next problem. So next problem is, if -2 to minus 1 fx dx is equal to 2, and minus 2 to 0, 2 minus fx dx, it is also 2. Then minus integration minus 1 to 0 fx, how much? Options are minus 1, 1, 2, and 0. So we are given this is equal to 2 and that is equal to 2. I start from here, from that minus 2 to 0, 2 dx, this part only, minus 2 to 0 fx dx is equal to 2. We can integrate it very easily. It is 2x minus 2 to 0 minus, we want minus 1 to 0. Achha. And minus 1 to minus 2 to minus 1, this value is also known to us. So it is minus 2 to minus 1 fx dx plus minus 1 to 0. Minus 2 to 0, it was minus 2 to 0. I have taken minus 2 to minus 1 and then minus 1 to 0 fx dx. So that it becomes 0 plus 4, lower limit, minus 2 to minus 1 fx dx, minus 2 to minus 1 fx dx, this is also 2 given, plus minus 1 to 0 fx dx. And it is actually, this is given as 2. So this is equal to 2. So that this is 2, cancels with that. So minus 1 to 0 fx dx is equal to 0. 0 is answer. So this is correct option. Next. Zero to 4 pi mod of sin x plus mod of cos x dx, how much? Option is 4, 16, 8, and 2. Now, as I told you that sin x is a periodic function of period 2 pi. Cos x also a periodic function of period 2 pi. But mod sin x, it is a periodic function of period pi. This one is mod sin x plus mod cos x. It is a periodic function of period pi by 2. Its period is pi by 2. So that this can be written as 0 to 8 into pi by 2, 4 pi, mod sin x plus mod cos x dx So that, and because it is a periodic function of period pi by 2, so this can be written as 8 into 0 to pi by 2 mod sin x plus mod cos x dx. It is equal to 8 into 0 to pi by 2 mod sin x dx plus second part 0 to pi by 2 mod cos x dx, third bracket. Achha, now that integration, it is 0 to pi by 2 mod sin x. Actually, to integrate it, we have to omit mod sin. But sin x, you see, is all along positive within that interval. So it is equal to 8 into simply sin x dx plus, same case, cos x is all along positive in first quadrant, that is 0 to pi by 2. So that it is positive, so we can omit mod sin. Now, very easily you can integrate it. It is equal to 8 of, its integration is minus cos x 0 to pi by 2 plus 8 into, its integration is sin x 0 to pi by 2. So that when I put x is equal to upper limit pi by 2, this becomes 0 minus lower limit, so minus positive 8 into 1 plus 8 into, when I put pi by 2, it is 1, this for this it is 0. So that 8 plus 8 is 16. So 16 is correct option. Next problem. Next problem is, this is a simple problem, minus 1 to 1 mod x plus minus 2 box function integral part of x dx. How much? Option is 3, 1, minus 1 and 4. So I can write it as minus 1 to 1 mod x dx. Then this minus 2 into integration minus 1 to 1 box x dx. Now you see, mod x is an even function, and interval is from minus 1 to plus 1, that is symmetric interval. So I can write it as 2 times 0 to 1 mod x dx minus 2 times, this is integral part of x function, so I write it as minus 1 to 0 plus dx, 0 to 1 box x dx. Actually, you see, it is a box function, and I have taken there two consecutive integers, minus 1 to 0 and 0 to plus 1. So two consecutive integers as lower limit and upper limit. Achha. In that interval it is positive. X is positive, so mod x is x. So 2, 0 to 1 x dx minus 2. It is actually box x. If the x ranges from -1 to 0, -1 to 0, two consecutive integers, so it is in fact lower limit of that, -1 dx, -1 to 0 plus. Same case here, 0 to 1, two consecutive integers, and x lies between 0 to 1, and this will be equal to 0 into dx. So that it is equal to 2x square by 2, that is x square from 0 to 1 minus 2 into, this is -1 dx, its integration is minus x so that it is equal to minus x, integration is minus x from -1 to 0, and it is simply 0. So that it is equal to 1 minus 2 into 0 and minus and another minus plus. This minus, actually minus, in fact this become plus, this become plus. No, 0 minus minus x, so that it is equal to 3. This is correct option. Next, the next problem is a to b root over x by root over x plus root over of a plus b minus x dx, how much? Options are half of a plus b, half of b minus a, b minus a, and a plus b divided by 4. That problem is given in WB JEE 2012. One property I told you, the property is a to b fx dx is equal to a to b f of a plus b minus x dx. Applying this formula, so before that, suppose this is your I is equal to that integral. So it is a to b. Now apply this formula. This is root over of, this formula is how, what is that formula? For x to be replaced by a plus b minus x, a plus b minus x by, this is same case, a plus b minus x plus root over of a plus b minus, for x to be replaced by a plus b minus x dx. is equal to a to b root over of a plus b minus x by root over of a plus b minus x plus this is root over of x dx. So I have started from I is equal to that, is equal to this, is equal to this. So this is also equal to I. So that we get 2I is equal to 1I is this, other I is that. So that it is equal to a to b root x by root x plus root over of a plus b minus x dx plus second I is that a to b root over of a plus b minus x by root over of x this one plus root over of that a plus b minus x dx. Limit is same for both the cases, denominator is same, so numerator will be this plus that, that is this, so that it is equal to a to b dx only, so that it is equal to x a to b, so that it is equal to b minus a. Hence I, actually we have to find the value of this, that is I. So 2I is equal to that, so I will be equal to b minus a by 2. So this is correct answer. Next, next problem is zero to pi by 2 root over of cot x by root over of tan x plus root over of cot x, how much dx. Options are 1 pi, pi by 2 and pi by 4. That problem was given in to solve the problem. Let us apply the fourth rule. Fourth rule, I remind you, 0 to a fx dx is equal to same limit 0 to a f of a minus x dx. That is simply x to be replaced by a minus x. In this case, a is our pi by 2. Suppose this is our I. So I is equal to, applying the fourth rule, this is equal to 0 to pi by 2 root over of cot of pi by 2 minus x by root over of tan pi by 2 minus x plus root over of cot pi by 2 minus x dx. That is equal to pi by 2, this becomes tan root over of tan x by root over of, this is cot x, this is tan x. So it is actually, this is equal to that, so it is also I. This is I, this is also I. So adding them, we get 2I is equal to 0 to pi by 2. Denominator for both the cases is same. Numerator is root over of cot x plus root over of tan x dx, so that it is integrand is 1, 0 to pi by 2, 1 into dx, so that x 0 to pi by 2, so that pi by 2. So answer is, we have to find I, 2I is equal to that, so I is equal to pi by 4. So fourth option is correct. Next, next problem is zero to pi x f of some function of sin x dx. How much? Options are pi f of sin x, pi by 2 f of sin x, pi and 0. And that problem was given in WBJEE 2008. So we have to find this, and these are the options. Let us suppose that it is I. F is any arbitrary function, we don't know what is that, and answer is also in terms of f. For that purpose, let us apply fourth rule over here. So this is equal to 0 to pi. Fourth rule, it is a minus x. To replace x by a minus x, f of sine of a minus x dx, it is equal to 0 to pi minus x f of, this is also sine x dx, is equal to pi 0 to pi f of sine x minus 0 to pi x f of sine x dx, so that it is actually equal to, this one is nothing but that. So once again it is I. So I is equal to this minus I. So 2I is equal to pi times 0 to pi f of sine x dx. We have to find I. So I is equal to pi by 2 into that. So this option is correct. Next, integrate this 1 to 5. This is third bracket. Mod of x minus 3 plus mod of 1 minus x dx. Two mod functions are there. Its options are 14, 6, 12, and 18. We have to integrate two mod functions. So first of all, remove mod sign. For that purpose, let us break into two functions, 1 to 5 mod x minus 3 dx plus 1 to 5 mod of 1 minus x dx. Now first mod function is x minus 3. Let us see, it will be 0 at x is equal to 3. At x is equal to 3. Before that, at 1, 2, it is negative. So let us break it like that. 1 to 3 mod of x minus 3 plus 3 to 5 mod of x minus 3 dx. And it is 1. It is 0 at x is equal to 1. After that, it is all along negative. So take (1 to 5) mod of 1 minus x dx. In that interval 1 to 3, it is negative. So it is 1 to 3, 3 minus x, it is negative. So that's why I write it like that. Plus, here in this interval it is positive, so that it is equal to x minus 3 dx plus, in that interval 1 to 5, it is negative or 0. So it is negative. So it is equal to 1 to 5 x minus 1 dx. Now nothing is there. Very simply, very simple cases are left. So simply integrate. Its integration is 3x. This is x squared by 2 and so on. Now put upper limit and lower limit, and answer will be, after simplification, answer will be 12. Next. So next problem is, for all integral values of n to n plus 1, fx dx is equal to n square. Then find the value of minus 2 to 4 fx dx. It is given in the problem is, you see, lower limit and upper limit are two consecutive integers. N is integer, it is given. So integer, n plus 1, another integer, two consecutive integer. So its value is n square, that is square of the lower limit for all values of n. So this can be written as, you see, this is minus 2 to 4 fx dx is equal to -2 to -1. I have taken two consecutive integers, fx dx, then plus -1 to 0, fx dx, plus 0 to 1, fx dx, plus 1 to 2, fx dx, plus 2 to 3, fx dx, plus 3 to 4, fx dx. Actually, I have arranged so that all the limits, I mean lower limit and upper limit, are two consecutive integers. When this is the case, its answer fx is not given, but answer of that is n square. So this is actually equal to minus, it is n plus 1, minus whole square. This is -1 whole square. This is lower limit means 0 whole square. This is 1 whole square. This is 2 square. This is 3 square. So it is 4 plus 1 plus 1 plus 4 plus 9. So it is actually 5, 6, 10, 19. Oh, options I have forgotten to give you the options. Options are, just 1 minute. Options are 25, 23, 19, and 18. So this is correct answer. Okay, today is up to this. Next day, we take few more problems from this chapter. It is very important for competitive exam. This chapter is very important. So I will solve some more problems next few days. If you like, if you think that it is helpful for you, please subscribe it, and before that you like it, share it. Thank you.